Hi folks, we're going to take a look at number 19 from the Trig Identities worksheet. So they were going to try to prove this identity here, and I think it's pretty clear that we're going to have to be starting with the left-hand side. Okay, so we'll start with the left-hand side. Gives us a lot more opportunities to do some manipulation. So now let's just say that there's a long way of solving this problem and the short way, and I'll tell you how to solve the long way, so if you ever get stuck, you can always use this as an option, but I'm certainly not going to do it. And here you can just apply your subtraction formula for sine, okay, and then write that out, and then write cotangent as 1 over tangent of pi over 2 plus x, and then apply your addition formula for tangent. And then, of course, you're going to have something extremely big and ugly to try to simplify, okay? But what I'm hoping you're going to see here is these pi over 2's, plus x and minus x. Okay, this is hopefully going to give you an idea to look at those correlated angle identities. Now, because you're going to have the identities sheet at your disposal, you might as well just use it. So we look here and we see that we've got sine of pi over 2 minus x, and we see that we can write that in a much simpler fashion because sine of pi over 2 minus x is just equal to cos x. Okay, now remember, this sheet does not have all the possible identities, so it's got everything for sine, cosine, tangent, but not for cosecant, secant, cotangent, but it's the very similar identities. So here, if I'm looking at cotangent of pi over 2 plus x, okay, I'm going to focus in on tangent of pi over 2 plus x. So tangent of pi over 2 plus x is going to be equal to negative cotangent of x, whereas if it's cotangent of pi over 2 plus x, that's just going to be equal to negative tangent. So while that one is not written down, you should be able to infer that from the one that you are given. Okay, so from our identity sheet, that means that I can write, instead of sine of pi over 2 minus x, we saw that that's equal to cos x, okay, and cotangent of pi over 2 plus x is just going to be equal to negative tangent of x. Okay, now let's say you didn't have your identities worksheet with you, or this one here you weren't sure about. You can always use a diagram to help you out. Okay, so remember, when we're working with these correlated acute angles, so here, if that's my angle x, pi over 2 minus x, I can draw in the first quadrant, where x now is to the y-axis, and I know that sine of this angle is going to be equal to the cosine of that angle. They're going to have the same, they're both positive, so same sign, SIGN. Okay, so that's just going to be to cos x. Whereas when we look at pi over 2 plus x, that's pi over 2 plus x, that's going to be in the second quadrant. Okay, and so here, cotangent is negative in the second quadrant. So cotangent of pi over 2 plus x is going to be equal to the negative of the tangent of x. That's in the first quadrant. And so another way of deciphering these two. Okay, but now that I have that, again, I've got sine x on the other side, so it makes sense to turn everything in terms of sines and cosines. So I'll leave this cosine x, and here I'm going to rewrite tan x, or negative tan x, as negative sine x over cos x. And here we see that we can reduce the cos x in the numerator and the 1 in the denominator, and what we're left with is just negative sine x, which is just equal to our right-hand side. So this identity's been proved. Okay, so just to recap, anytime you see angles like pi over 2 plus or minus x, 3 pi over 2 plus or minus x, you should be thinking of using your correlated acute angles. Okay, so these identities here. Keep that in mind. All right, that's it for this one.